Hello friends, welcome to ACE Engineering Academy online platform where we have started ACE Preparation League. My name is Abhishek Sharma and in today's class I am going to discuss expected question in GATE 2022 from C programming language. Now, programming in C is having a very good weightage in GATE examination, and we can expect every year, we can expect 3 questions from this particular topic. This has been the trend from the last many years, and that makes C language as one of the important part in GATE preparation. Now, here I have summarized some topic where the question will be discussed from, and that is we will talk about operator precedence and associativity, operators separately, control statements, switch statements, pointers, function and pointer arithmetic, which is mainly used in case of arrays, array and pointer, and finally storage class. Now, whenever the question asked in GATE examination, they do not pick a single concept, means they may pick 2 or 3 concepts from this particular topic and create a single question. My discussion will be around this, and in that we will be discussing almost every topic mentioned here. Now, I want to start with the simple thing, and for that I have taken expression, and this is the arithmetic expression that we are having, and this is the first question, you can say, as a warm-up exercise. I want to start with this. Now, to make the session interesting and fruitful, I will suggest you to also, whenever question appears, you start solving them and then match your answer rather than me to explain this question. So here we have 3 different expressions, and these are the arithmetic operators that we are using in this case: multiplication, plus, and here modulo, division, plus and minus. Now, simple rule here in this case is to evaluate this expression, we want to find out the value, what are the value that will be stored in I, k and x. One more point, this variable I, k and x are integer variables. So they are going to store only the integer value. So I hope that you are already prepared with this programming in C and different parts of it, and now you are ready to answer for this question. Let's discuss this question starting with the A here in this. Now we know that here to evaluate this expression I need precedence and associativity. So where it will come, what is the basic rule for precedence and associativity? Basic rule is the operator that I am having is plus, minus, multiplication, division, and in this multiplication and division having higher precedence than plus and minus. Now what about this? Here in this case, this expression 2 multiplied by 3 divided by 4. So now here the focus will be on this, in this case the operator which is operand, which is 3. For that, left and right both sides you have the operator of the same precedence, multiplication, division, same precedence, and for an operand, if the left and right side have the same precedence of the operator, then associativity comes into the picture. Multiplication, division, plus, minus, multiplication, division, same precedence, plus, minus, same precedence, and they are left associative operator. That means for this expression, evaluation will be in this way. Here no issue. Here also 5 divided by 8. So I'll write a sub expression over here, 3 into 2, 6, 6 divided by 4, plus this one will become 4 divided by 4, which will be evaluated to 1, plus 8 minus 2, and 5 divided by 8. Another rule that is important over here is that whenever you are performing operation between integer and integer, 5 divided by 8 will not result in any float value. Integer arithmetic operation integer will result in integer. Float and integer will result in float, and float is going to result in float. 5 divided by 8 will be evaluated to, in this case, will be 0. 4 divided by 6, again the same rule. In this we have 1 and this is 1. This is 8 minus 2 plus 0, and you can see here this expression is going to evaluate to 8. This quotient, the first expression is going to evaluate to 8. 3 into 2, 6 divided by 4, 4 divided by 4, 8 minus 2 and 0. Answer for this question is 8. So I hope you have done this and you agree with this answer. Simple expression for C language. Now the second expression is not like here. Now if you are able to understand this, even if you are not familiar before, then you can now attempt this one as well. Now here we have same rule, that left associativity, and here 3 divided by 2 will be executed first because of left association. Though for left and right operand 2 we have the operator with the same precedence, but 2 will go with division. So in this case, what this will be evaluated to, 3 divided by 2 will become 1. 3 divided by 2 will become 1, multiplied by, in this case, is 4, plus here again 3 divided by 8 will be 0, and then plus 3. This is again multiplication and plus 3. This expression, second expression, will be evaluated to 7. So 4 plus 3, and first is 8, next is 7. And the last one is having a very small expression where we are using modulo operator. But in this modulo operator, our second operand is negative. So what will be 2 modulo minus 8? 2 modulo 8 will be 2, we know this thing. What will be 2 modulo minus 8? So for that we need to go to this division part here in this cases, that how division works. Now here I am writing a few divisions. 7 divided by 3 and 7 divided by minus 3, minus 7 divided by 3 and minus 7 divided by minus 3. Now this is division, and I am just writing the value of here quotient and remainder for each cases, Q and R, quotient and remainder for each cases. Quotient and remainder for each cases. Now here the simple rule of the division, that quotient into divisor plus remainder is equal to your dividend. So that rule we are going to use here in this cases. So 7 divided by 3, here the quotient part will be 2 and remainder will be 1. 3 into 2, 6, 6 plus 1, 7. Here in this case minus 3, quotient will be minus 2 and remainder will be 1. So 3 into minus 2, 6, 6 plus 1, 7. Here quotient part will be, in this case, is minus 2. 3 into 2 minus 6, remainder will be minus 1 in this case for this. And here again minus 3 into 2 quotient part and remainder will be minus 1. Okay, so that is the answer. And the rule here in this case is, now you look at the remainder and the dividend. Now if dividend is positive, remainder is positive. Dividend positive, remainder positive. Dividend is negative, then remainder is negative. Dividend is negative, remainder is negative. So dividend positive, remainder will be positive, and dividend negative, remainder will be negative. That is the basic rule that it works with. And here in this case we do have dividend as positive, 2 is a positive number. So here remainder will also remain positive. You can check this answer. This will be 4 plus 2. Answer for this last expression will be 6. Okay, so I'll repeating here in this case is dividend positive, remainder positive, and dividend negative. Remainder negative. So that is my first question for evaluating the expression. I hope you have done this one, and in this case answer is 8, 7 and 6. That is the answer here in this case is 8, 7 and 6. That is the first part. Let's move to the next question here. Now this is a numeric answer type of question where again I am focusing on operators in this case. And here the operator that I have taken in this case is this bitwise operator, bitwise AND, bitwise OR, bitwise your left shift and bitwise right shift. And we are doing very small thing that we are storing the values here in this in IJKL, and finally we are getting sum of it. So again I would say that very simple question, and that as I said operators, so this again the next question is from operator. In GATE 2014, which was conducted by IIT Kharagpur, and this year also IIT Kharagpur is the organizing institute, they have asked a question related with this operator. Okay. That doesn't mean that this year again they are going to ask question with this particular operator. Generally what I find here, the trend is set by the previous year paper rather than that time what was what they have conducted in, let's say, way back in 2014. So generally my guess, that is also not very much like always true, but the guess is that the recent papers like 2021 will have more, will set the trend for 22. But though this is one information that in 2014 they have asked a question with this operator, that is a left shift operator. So simple question, 4 statement, and then just add them up. The value of unsigned character is A and B is 7, and we have unsigned character in this case is IJKL. Now they can store integer value. They can store integer value in this cases, and we can print the integer value stored in them. So A is here in this case is assigned as 4, and I'll take a for understanding, better understanding purpose, this is A4, and now I need a bitwise representation which will be equal to 0 and 4, 1, 0, 0, 0, that is 4. And B is in this case is 7, which I'll again represent in 8-bit, which is not required actually. 0 and we have 1, 2, 5, 0, so 3 occurrences of 1, 111. Now we'll perform some operation, and these are the result of the operation. In this case I'm going to perform A and B AND operator, and with that you can see that AND operator is going to result only this bit will be equal to 1 and rest all the bits will be 0 in this case. In fact this bit will be also not 0, this will be also 0 in this case. I'll write it in a proper way. So this is 7, and in this we do have, I do have extra bit over here, 1, 2, 3, 4, 5, okay. So this is your 4, and now I'll write 7 in this, so 0, and this will be 1, 1 and 1, okay, 4 bit, this is 4 bit and this is 4 bit, and now I'm going to do AND operation. And in that AND operation only this bit will remain 1, and that means the answer will be this, which is equal to 4. When you do the OR operation between A and B, and in this case A or B, and in that 0, 0, 0, 0, and in this will be 0, and it will be all bit will be 1 in this case. You know the rule for R, so that will be 7. Now we are shifting right B. So B is being shift right here in this case, 3 positions. Now the rule here I can show you bitwise what will happen in this case, but the rule for left and right is very simple. Whenever you shift right, okay, whenever you are shifting right and when you are shifting left, in this case we are shifting left here in this case, left shift operation. And that means this 1, 1 position they will be shifted to this position. So now I'll take from this to this, 0, 0, 0, and I'll take another 0, and that will be 3 ones. And last bit I will introduce here, a new bit in this case is 0. So I don't need to do this thing. The trick here in this case is that it is 7, this will become 14, one shift. Another shift, it will become 14 multiplied by 2, it will become 28. Another shift, 28 multiplied by 2, this will become 56. So now when we are shifting left, it is equivalent to the multiplied by 2, and 3 shifting, B3 shifting, will make this value equal to 56. The last one is shifting of B 4 times to the right. Now the left shifting is multiplied by 2, and the right shifting is divide by 2. So now if you feel here that B value has been changed to 56, again look at this. There is no assignment in when we are shifting left B by 3 position. It is not assigned, it's just an expression B, then left shift by 3 position, 56. What is the value of B? B still is 7. The value B is still 7. And now you do 7 4 times shifting. B is still 7. And shift it for 4 times. What will happen? 7. For first time shifting, 7 divided by 2, it will become 3. First time shifting. Second time, 3 divided by 2, it will become 1. Only integer part. Third time shifting, 1 divided by 2, it will become 0. In third time shifting, it is becoming 0. And obviously for fourth time shifting, B value will not change. The value that will store in L will be 0. So this will become all zeros. All 8 bits will be 0. And that value is 0 over here. Answer is what? What value it will print? And for the printing, we are saying I plus J plus K plus L. What is I? 4, J, 7, 11 plus 56. Answer for this question, what is the value printed output of the program? 67. Okay, and that is 4 plus 7, that is 11 plus 56. 67 is the answer for this question. Don't sit idle. Keep on answering, keep on practicing. Because examination is just, how many days you can say? Maybe 40? 40 odd days, 40, 45 days. And by this time everything must be clear to you. And you should answer everything over here. 67 is the answer, and the focus for this question is on operators, bitwise operator. And the purpose here is that because there is a question from operator in 2014. So that is the answer here, and 7, 4, 11 and 56, the answer here in this case is 67. That is the explanation I have already done for you. 67. Okay, so now here we are with the new kind of type of question, which is multiple select question, MSQ. And for right now you cannot go and answer this question because you don't know the options. Actually options are there, question is big. So just few thing about MSQ. The first point for MSQ is that it's not mandatory that there will be more than one answer correct. There can be a single answer also may be correct. And second is there is no negative marking. For NAT also there is no negative marking. For this MSQ also there is no negative marking. So now here we have these two function and function 2, and now this function is about the behavior, how this function is going to behave. This is the options A, B, C, D. Okay, so this is the function, and this function is fun1c, which is taking a unsigned integer num, and we have a while loop for this, and some sort of situation. And here there is one more operator that just now we have done. There is a left shift operator, num left shift equal to 1. And that means the bit value of num, which is unsigned integer, is going to left shift by 1 position. And just now we have done that the left shift is equivalent to divide by 2. So that is something over here. Similarly here also we have a while loop, we have a count plus plus, here also count plus plus, and we do have num is equal to num divided by 2. So now one is a right shift operator and another one is divided by 2. I hope both is clear to you. Return count, both are doing same thing. The question is that is these two functions are same? Okay, are they doing the same thing? Count plus is there, count plus is there. Now only thing difference is what? There is a condition of num and there is a condition of num greater than equal to 0. Okay, that is the difference here. Apart from that, everything is same here. Count is initialized to 0. Here also we do have a count initialized to 0. Now these are the options that it says that both function produces the same output and it's MSQ, so we need to evaluate or check all the options over here. So we do have here in this case is, suppose I take the value, let's say num as 10. So now what it will do here in this case is 10 divided by 2, that is equal to 5. Count will be incremented to 1, right? So now count will be incremented to 1, count value will become 5. 5 count will be incremented to 2, count will become 2. Count will be incremented to 1, count will be incremented to 3, value will become 1, and count will be incremented to 4, and then value will become 0, and finally it will terminate. I have taken a small value in this case, 10 I have taken. So 10 count will become 1 and then 5. Then 5 count will become 2 and then it will become 5 divided by 2, that is 2. Count will become 3, 2 divided by 2, it will become 1. Count will become in this case is 4 and finally it equals 0. While 0 it will terminate. Now here let's check the same thing here. Let's take a small value 10. Even you can take more smaller value than 10. 10. 10 greater than 0, true. Count plus plus, count will be 1. Value will become 5, same. Count again 5 greater than 0, true. Count will become 2. The value 5 divided by 2, that will become 2. Count will become in this case is 3. Value will become 2 divided by 2, 1. Count will become in this case is 4. And the value will become in this case is 0. Now here 0 greater than 0. I'll check this condition here in this case is 0 greater than 0. Is it true? Answer is yes, it is true. So if it is true here in this cases, then here the value will become in this case is 5 and then again 0 divided by 2, 0. Now what is happening in this case is this function 2 is looping after reaching to this value 0. And that means there is a termination, there is no termination for this particular function. And with that I can say both function and function 2 produces same output. This is not correct. This is not correct. Function 1 terminates for all the values of num, but function 2 does not terminate for all the values of num. Yes, because what will happen here is that finally you will, any value, even or odd number, 3 divided by 2, that will become 1, and 1 divided by 2, that will become 0, and it will be keep on looping. 0, it is not terminating. So what will happen? Function 1 terminates for all the values of num, but function 2 does not terminate for all the values of num. That seems to be a true statement in this case. Function 1 terminates, function 2 does not terminate. Function 2 terminates, no, this is false. We have already seen function 2 does not terminate, that is false. The last one is changing function 2 statement to while num greater than 0. Will make function and function 2 to produce same output. Let's go back here. Now greater than 0, no equality. If I change num, this condition num greater than 0. Now for num greater than 0, this is going to run for 1. 1 greater than 0, yes, it will run over there, 1 greater than 0. Also this loop, this will also, if it is num is 1, it will run for and do the count plus plus. After that what will happen? There will be count plus plus. Here also count plus plus. Then in this you have num is equal to num divided by 2, and that means equal to 1 divided by 2, that will become 0, and next time 0 greater than 0, num greater than 0, 0 greater than 0, that will become, in this case, will be false, and it will return the count. So yes, this is also correct here in this case, that if I change this condition to rather than num greater than equal to 0 to num greater than 0, then it is going to terminate, and we can go here for answer for this question as B and D. While going through the question asked in set 2 previous year in 2020, what I find here, and I still remember the question is from graph theory, and in that graph theory question, in a single question there was option regarding the back edge of DFS traversal. There in a single, that same question we have a strongly connected component, commenting about a strongly connected component. In the same question we need to find out the topological ordering. There is no, like, we need to confirm that the graph does not have a topological ordering, and in the same question we need to find out the reachability, whether one node, whether all the pair of nodes basically reachable from one to another. MSQ can make the difference depending upon how much time you are devoting in the examination. Because for a single question, for a 2-mark question, solving 4 questions is not a wise idea. So even you are able to solve, and that too also, if you look at the problem instance, that problem consists of 16 vertices. So look at the problem size and look at the 4 different problems: topological, strongly connected component, reachability of the vertex, and finally you have this the back edge calculation. 16 vertices, DFS traversal, back edge is related to that. So we have to, whenever we in the examination, we have to be very careful with attempting MSQ. It should not be based on the gut feeling, and it should not be related with that particular concept. You first wisely judge how much time it is going to take to solve that particular question, and then go for attempting those questions. Okay, so the advice for 2022 will be that be careful with MSQ. If it is like here, we can solve the question not asking the same thing, like here it is only about function 1 and function 2 relation between that, doable. But if the same thing asks 4 or 5 different, for all the 4 different things he asked regarding not termination, actually producing output and termination, then you are the best one to decide whether go for it or not. But be careful with that. Let's move to the next question here. So that is the same part here for that question actually, and B and D, as we have figured it out that B and D is the correct answer for this. Now here this question I have taken, and I just wanted to say something about one more operator, that is the only ternary operator that we are having in C, the ternary operator. And very simple program, like here in this case we have 1, 2, 3, 4 lines of the code actually. So we do have very simple program in this case where we have 4 lines of the code, and it says that x3, y4, z4, and the whole idea is about the ternary operator. Ternary operator treats this as a relational expression. The first part of the ternary operator treats here in this case as a relational expression. Then this is a truth value, true value, if this relational expression is true, colon, the next value is the false value, colon, false value. So true and false, that is the based on this relational expression, and that means this relational expression is going to evaluate to either 1 or 0. Now here let's have this expression z greater than y and y greater than x. What is the value of z? 4 greater than or equal to y, which is 4, and greater than or equal to x, which is equal to 3 in this. So 4 greater than equal to y and greater than equal to x, this expression. Now the question here again comes that what is associativity here for the operator that we do have is 4, the middle 4. Middle 4 is associated with operator on the left hand side or right hand side. And for that, your reference I have written, or I have taken this the precedence operator here in this case, and where we have only 3 categories of the operators are right to left. So this is one category. This is precedence as well as associativity. So right to left here in this case, we have prefix, increment and decrement. Unary generally we don't use. Address of and dereference, these are also operator dereference and address of are unary operator. The unary plus and minus, address of and dereference, that is most common operator in the examination, are right to left. Okay, prefix, increment and decrement, and dereference and address of operator, address of operand actually, is right to left. Another right to left operator is your ternary condition, but here do not apply this ternary condition. You must have more than one ternary condition. In that case, this will be applicable. In our question, we had only one single ternary operator. So right to left is what? Prefix, increment, decrement. Ternary operator is a right to left, and assignment and all categories of assignment. All assignment I would say. Okay, plus equal to, minus equal to, multiplication, modulo, and XOR or ref shift right shift. All category of equal to operator is your right to left. So you can remember them. Prefix, okay, prefix, increment and decrement is right to left. Ternary operator, here only single ternary operator. Ternary operators are evaluated from right to left. And equal to whatever equal to with any operator, that is also right to. Only 3 categories of the operators which evaluated from right to left. Otherwise every other operator is going to evaluate left to right. Here also left to right. This is not equal to, this is relational operator. Okay, greater than equal to, and this is greater than equal to. This is relational operator. This I am talking about assignment actually. Okay, assignments evaluated right to left, but this evaluated left to right, and now I evaluate this. 4 greater than 4, true or false? This is the parenthesization. 4 greater than 4, true? Yes, true. So 4 greater than 4 will be evaluated to 1, and 1 greater than equal to 3. Okay, this will be true or false? 4 greater than 4, true. So that is answer will be 1. 1 or 0? 1. And now the next evaluation is 1 greater than equal to 3. So that is what? That is false. And that means this is the truth value, this is the false value. Answer for this question is 200. B is the answer for this question. MCQ. So based on this, precedence greater than or equal to operator is of associativity, left associative. This expression is printing the value 200. All are, you can verify, all the question you can verify by running them. So that is about the operator greater than equal to and its associativity. And with that also I commented about the associativity of the different categories of the operator. Remember them. Moving to the next question. This is a multiple choice question that we are familiar with. We know this, and this question I have taken from the control statement, and that is execution of the for loop. Now I still remember that there was one question in 2019 where the 3 different parts of the for loop, this is the 3 different parts of the for loop, okay, and I still remember that in that 3 different parts, rather than writing expressions and statements, this is gate question actually, they have written function calls. You can verify. This is a question, gate question. And in rather than writing here, what do we, what we study in academics? This assignment, condition check, increment or decrement. Okay. So now here every place, but the thing is that you can have assignment, regular one, assignment, condition check and then increment or decrement. You can also have in these places the function calls, or you can left them blank. So for just solving this kind of the question, this I believe that this will be very handy to understand the for loop, the timings actually. For loop is all about timing. So what we identified here in this case, there is no assignment. We don't have any assignment in this case. Then for condition, I have written the only value j. Now in C language, we have one thing, that anything that is non-zero, any value which is non-zero is true, and any value which is zero is false. So we don't have any separate variable true and false in this case. Any non-zero is true and any zero value is false. With that j, if you look at this, for there is no assignment, already I has been assigned to 1, j value is assigned to 1, that means this condition is true. Had it been j is equal to 0, the condition will become false. Simple. Then we have a printf, a function call, fine. Then we have a statement, a complex type of the statement where one more time your focus will be on the operator, that is a post increment operator, I plus plus less than or equal to 5. I plus plus less than equal to 5. So now we can convert this for loop to a while loop by using this, and I'll just say the timing here in this case is, then we'll come back to that question. For I is equal to, let's say 0, I less than 5, and here it is I plus plus, and I have a statement over here, suppose statement, then I can convert this one to an equivalent while loop by writing this way: I is equal to 0 while I less than 5, then I'll write here statement, and then I will write here I plus plus. Okay, this is the timing. So assignment will be done. Every time you are going to the body of the loop, you will check the condition I less than 5. Then a statement, the body of the loop will be executed, and finally you are going to perform the I plus plus operation, which is increment, that is the last statement to be executed. So here also we have the same notion over here, and I'll just, for better understanding, I will just convert this into a while loop where already the I equal to 1 and j equal to 1 condition is there. I is 1 and j is 1, and I'll write while j, and then I will write here the condition j that needed more attention. J is equal to I plus plus less than or equal to 5, and then finally the function call, the third part, the printf, and I'm writing %d, don't go into the syntax part, I comma j. This. So this I have written in a for loop, I have written in a while for loop, I have converted into a while loop, you can say. Now while j is 1, true. Now I'll come to this part. Now what is the property of the post increment? That here you have I plus plus less than equal to 5, but plus plus is a post increment operator. Then equal to is having least precedence, and for that reason this will happen later, but we will have only this part, and which will be I less than equal to 5. This will be executed. After this execution, I will be incremented. Why? It's a post increment operator. So here I will be incremented in this case, that is the post increment operator, I plus plus less than equal, I is less than 5, I is 1, 1 less than 5, true, and that result will store in j. So j value will be 1, true. Now after this expression, I will be incremented and I will become 2. And when you come to the printing, the first value it is going to print is 2, 1. 2, 1. So we have B and C as the option for printing the value 2, 1. So now I'll just because it is going to execute again and again, I'll just prepare a table for j is equal to 1. This expression executed and j is equal to 1, we have gone here, and here the I value, after this I value becomes 2 and printing becomes 2 comma 1. So I compare I is equal to 1. I started I is equal to 1 and j is equal to 1. When I come back here, it will be I is equal to 2 and j is equal to 1. Now comparison will be to 2 less than 5, yes. So j will remain 1 at the end of it, but I will be incremented to 3 and the value it will print is 3, 1. This is the value of j, the new value of j, I3, 3, 1. Then I will be equal to 3 and j, we know that this is 1, the j part is 1. Now comparison will be 3 less than equal to 5. So if 3 less than equal to 5, yes, true, so j will be, I will be after that incremented to 4 and it is a true statement, 4, 1. So 2, 1, 3, 1, 4, 1, fine. So I is 4 and j here in this case is 1. 4 less than equal to 5, true statement. I will become 5, the value when it comes to the printing 5, 1. Now I is 5 and j is 1. Now 5 less than equal to 5, true, right? 5 less than equal to 5, true statement, and that will make I is equal to 6, and when it comes to the printing 6 and 1. I compared 5 less than equal to 5, but it comes to the printing I plus plus incremented value. What is j value last iteration? J is still 1. And if j is 1, while j will be successful in this case? If j is 1, while j will be successful. So again we'll come here and I'll just focus on this part. What I will compare, j is 6, so I is 6, I'll compare 6 less than equal to 5. As I'm doing 6 less than 5, now it is false. So now here, because you have entered with j is equal to 1, I will be equal to 7. And now when you compare 6 less than 5, it becomes false. When it comes to the printing, it will be 7 and 0. Last iteration, concentrate. So here when it comes to the printing, I will become 7 and 0, and that time this while loop will terminate. So now my series of values is 2, 1, 3, 1, 4, 1, 5, 1, 6, 1. And before terminating one more time, that will be 7 and 0. The answer for this question is C. C is the answer for this question. That this question deals with the timing in a sense that which part of the for loop will be executed when. And here I also have demonstrated that how can we transform, if where for loops are getting confusing, then how can we finally transform these loops into a while loop. Do remember that apart from the things that we know, this part can be a function call as well. The initialization part, the condition part, and the last increment or decrement part. So that can also be a function call as well. It's not wrong, it is a true statement, and it is not something that cannot be done. It can be done here in this case. This question deals with control statement. So it's a very good question actually, and we have not lengthwise it is small only, but again it summarizes concept related with this for loop. Let's move to the next question. So C is the answer for this. Now we have one more time the concept of the operator, which is a left shift operator and operator, and first time we do have a question which is based on storage class which is a static storage class. So we have 4 different storage classes: auto for local variable, static for global variable, but locals can also be declared as static, like here the foo function is having count variable as the static variable. Then we have a for loop over here, which is also having another variable. Main function is another variable declared as static. So now we have static variable. So now this question categorization, that's what sometimes it is very difficult. This question is from operator as well as storage class. And that is how the questions are in examination. You cannot say that this particular question is for this particular topic. You must be aware of every topic in the examination. Let's solve this question here. We have 2 parts. This is a main function where we are having a for loop, and whenever you have the for loop, it's better to create a table sort of situation. This is I is equal to 4, again initialization is missing, and I greater than 0, and that means this loop is going to run for I is equal to 4, I is equal to 3, I is equal to 2, I is equal to 1. 4 times this loop is going to run. Second thing, we have to be very careful with the static variable. The property of the static variable is static variable retains the value during various function call. Meaning is that if I modify the value static int count is equal to 0, this is a declaration as well as initialization. There is a declaration of integer variable and there is an initialization as well. Now static variables declare an assignment, first assign only one time. Okay, so initialize only one time, declare and initialized only one time. This is the initialization. So if I call the foo function one more time, that doesn't mean that this will be again initialized to 0. That will not happen. Suppose during this course of calculation, the count variable has modified to 2, so it will remember 2, it will maintain that value 2. That is static variable is about. So now we will be focusing on this part first, that what is happening in this case, and here I have separated this main function, and we have already figured out that this loop is going to run for I is equal to 4, I is equal to 3, I is equal to 2 and I is equal to 1. 4, 3, 2, 1 this loop is going to run, and finally you are going to store the value of b's. B you are accumulating and finally you print the value of b. But for that I need to go for calling foo of I. So I will be calling here in this case is 4, 3, 2, 1 that will be called, and that is this function that it will be called here. I have separated it, foo static int count while a right shifting divided by 2 and then count and this operator and 1. Now, so now suppose a is called with 4, so a will be equal to 4 in this case. Now while a, I can do it because non-zero value. Now here a and 1. So now a and 1, and here because a is an integer and positive value it contain, I can have only this 4 as the value of 4 will be equal to this 0, 1, 1, 0, 0, 1, 0, 0, this. Now you are doing AND operator with 1. So AND 1 to 0, 0, 0, 1. Now you may be, you may feel why I have taken only 4 bits, because the rest of the bit will be zeros only. Okay, zeros because it's a positive number and 0 for positive, 1 for negative. The rest of the bit will be zeros only in this case. Now we are doing AND operator, and in this case the result will be 0. Fine. And that 4 zeros, and that means this count will be not added with 0 in this case. Now fine, then it will become 2. That means I am just repeating this, that because of right shift this will become 0, 0, 1, 0. And again you do the AND operation with 0, 0, 1. Again the result will be 0, and that means count will be again added with 0 only. So count is not changing. Now this is the first time shifting. Again it will shift and it will become 0, 0, 0, 1. And this time you do the AND operation with 0, 0, 1. and that means this time it will become 0, 0, 0. 1 will be the result of this operation, and count plus this will be adding to the value 1. Now this is the value of A, and one more time you shift it, it will become 0 and loop will break. That means count value, the first time when I is being called here, I is equal to 4, count is being initialized, count is equal to, in this case, is 1. Now moving here, and now if you see the pattern that every right shift will take this bit position into this next position, and then we do the AND operation with 1, bitwise AND. And that means this rest bit is 0. For AND, rest bit is 0. This is one of the concept of masking also, you can say. The bit that you want to check, that position is 1, and rest of the bit you make it 0. So we create the mask and we perform the AND operation. So something that is like that is happening in this. Now whenever there will be now the logic wise, whenever the LSB, least significant bit, will be 1, this position will contain 1. That time the AND operation will result in 1, and that time that 1 will be added to the count. And for that we are right shifting it so that we can check each and every bit position. So as many as times 1 will be in the LSB, least significant bit, that many times the count value, this AND operation will become 1 and count will be added to 1. Here we have only single 1, and that is the reason that this count is only incremented by 1. So this is for A is equal to 4. Let's pass A is equal to another value which is 3. And let's develop that sense that what exactly happening in this. And then we can generalize the situation. So for A is equal to 3, count is already 1. So A is equal to 3, the bit value will be equal to, in this case, is 0, 0, 1, 1, 3. And again we are doing AND operation, the first AND operation with this, and in this it will result in 1. Yes, that means count will be now 1 was there and count will become 2. Now why count will become 2? Because the count is a static variable. So count is a static variable, previous value is 1 and this value is 1 plus 1, that is equal to 2. So count is a static variable and 1 plus 1 it will become the value 2. Remembering the previous value. Now let's shift it one more time here, right shift. When I take this A and right shift, this is the second iteration I am running. In this it will become 0, 0, and 1. And this will also become 0, 0, 1. And again here in this cases, the value will be 1 and count will be incremented to 2. So count will be incremented to 3. Count will become, in this case, is 3. Count is 3. After that third part, nothing will happen. Why? Because this will become 0, 0 and 0, 0, 0, 1. Finally, what I can conclude is this, that this count will be incremented as many as time we are getting 1 into this. In which? In A. In bit value, in bit representation of A, how many times 1s are there? That is been counted by this while loop. The number of occurrences of 1. For 4 it was 1, but for 3 it becomes 2. And 1 plus 2 it will become 3. So now since I understand the logic, I can go for the next value without iterating down to the while loop. And I can say that what value it is going to return. Now I'll just see the B part here in this case. So for I is equal to 4, count is returning one value, and that we store the value of B, and B is 0, so B will become, in this case, is 1. B becomes 1. For I is equal to 3, we have already seen that this value is returning 3. Okay, count returning 3 because 2 1s are there. So 3 it will return, and in this case B will be added with 3 and B value will become, in this case, is 4. 3 plus 1, 4. Now for I is equal to 2, for A is equal to 2, this bit position, the bit value is 0 0 1 0, and in this case number of ones in this case is only 1, and that means the count is 3, count will become 4. 4 will be written over here and that will be added with b, so b will become 4 plus 4 and that will become 8. Finally, for a is equal to 1, this will become 0, 0, 0, 1, right? This will become 0, 0, 0, 1, and count will become in this case is 4 plus 1, and that is 5. 5 will be returned here, and in this case b will become 8 plus 5, that is equal to 13. So 13, and finally this printf b is going to print the value 13 in this case. 13 is the answer for this question. Complex, complex, but yes, there is a concept of the static variable in this, and then we have this loop which is basically counting number of occurrences of 1 in bit representation of a. That is what is happening in this case. So 13 is the answer for this question. Let's move to the next question. Answer for the previous question is 13. Now next question is category MCQ only. We have a multiple choice question, and here what I have done here in this case is I have used a concept of an array and pointers. This question is from array and pointer. Okay. So now order suddenly, we are having static variable and then we have array and pointer. So there is fine. We like at this particular instance we are more or less familiar with all the topic. Now here we have an array which is defined here in this case is 1, 23, 4 and 5. So most of the time for array questions we do have this 1, 23, 4 and 5, and for sake of better understanding I'll assume addresses in this, and I assume the address in this case, suppose this address is 100, this address is 102, this address is 104, and this address is 106. Now because we are dealing with pointers, we must be also familiar with these addresses. So these are the assumed values for the addresses. Now the next statement is a pointer, integer pointer b. Okay, we have an integer pointer b in this case. So pointing to an integer b, and it says that value, that integer pointer initializing int star b is equal to a plus 3. A plus 3, whenever you take the name of the array, okay, it represents address of the first element of the array. And in this case, address of the first element of the array we have assumed in this case is 100. So this expression will look as this 100 plus 3. Now, when 100 is an address of what? Address of an integer. Whenever you are performing addition to this, few operations are allowed for pointer variables, and one of the operation is the addition operation. So when address is an integer and you do plus 3, do not rush and add the value, because in this case pointer arithmetic will come into the picture. Pointer arithmetic, this is not a normal arithmetic. And pointer arithmetic depends upon the data type. It heavily depends upon the data type. Like here 100 is an address of what data type? That's why I have written here explicitly that this is an integer data type. Right? This is an integer data type. And 100 plus 3, if you consider the data type, this will be written as 100 plus 3 into size of the data type. This is pointer arithmetic. Normal and arithmetic 103, but 100 is not a numeric value. This is an address, and 100 plus 3 is size of data type. I have assumed that 2 byte, and that will become 100 plus 6, 106. 106 is the address that is going to store in B. So B value is going to store the value 106. 106 is the value that it is going to store. So now B is having 106. Now we have a printf statement where B is minus 2. So now we have B with index of minus 2, and that is equal to, we must know that how this bracket works and how does it open. If you are familiar, very good. Otherwise, this is the way the bracket open. B minus 2, this is the meaning of B minus 2 or B1 or B1. If it is positive, you add 1. But if it is minus, do the minus operation. And B is what? B is an address. So now what it is saying, dereference, value of B is 106 minus 2. Now again, if you are not understand this one, 106 minus 204, that is normal arithmetic. 106 is an address of an integer. So again, pointer arithmetic will come into the picture, and dereference 106 minus 2 into size, that is mandatory in this. Dereference 106 minus 2 into 2, and that is dereference 106 minus 4, and that is dereference 102. That is your answer, dereference 102. And in this case, for our arrangement, our assumption of the data value, the value stored in 102 is 23. This is going to print the value 23. B is the answer for this question. Okay, so this is the first part of our discussion, and we'll take a small break and then we'll continue our session. Hello friends, welcome back, and just now we have completed this particular problem, and here answer is 23. Just I want to rectify small thing. While explaining this question, might be in the flow I have maybe used the term left shift, but this operator is a right shift operator, okay, and right shift operator always divides the number by 2, and that is what is happening, that bits values are shifting right in this case. Similarly, maybe in a flow I have again mentioned that for this particular question as a left shift, but as the directions are suggesting here in this cases that this is also a right shift. So I haven't discussed the left shift operator in any instance except the first problem that we have taken over here, that this problem. So in this problem, this B is left shifted by 3, and the left shift is equivalent to multiplication multiplied by 2, whereas this operator, as it is suggesting that this is a right shift, and here we are doing divide by. So only this place I have used the operator which is a left shift operator, but maybe in a flow I have said left or right, something different. So this is a left shift operator, only one place, and for all other questions I have used the operator which is a right shift operator. This is also right shift operator, as well as for this particular question here also the operator is a right shift operator, okay. So just if mistakenly I've said that left shift, then all are right shift except the first question. So that is something about array and an index, and here answer is 23 as you have already responded to this. Friends, let's move to the next question for this, and here we have a switch combination of switch as well as a for loop, okay. So again a control statement, question from control statement. Where we do have switch and for loop. And I appreciate because the codes are very simple, immediately it comes in front of you, start solving them rather than noting it down, because that will be in front of you. So here we have, and these are the options that we do have. Now we have a main function, I is initialized to 0, and for again we have missing the initialization part, which is okay because I is already initialized to 0. Condition is I less than 20 and I plus plus. Now we do have a switch I, which will take the value of I and this switch to the cases here. We do have a default cases. The point to note here in this case is these are the case with no breaks. And immediately you must identify that these cases are not having break statement, and the meaning is that once a case becomes true, then all the subsequent cases will be executed as true till it gets a break or a termination, okay. So that is the small concept related with switch without a break. A break is not mandatory, default is also not mandatory, both are not mandatory, these are optional. So here we have I is equal to 0 and switch 0, and that means that case 0 will be true, and we don't have any break, so that means all will be added to the value of I, which is 0. So final value will be added in this case is 5, 5, 10, 10, 12, and this in this case is 16, and finally it will break. And for parenthesization you can say, I hope it is indented properly, that we do have a printf statement over here which is printing the value of I, and that is equal to 16 in this. So the first value it is going to print here in this case is 16. Now the only thing that this question is about the second value, and you must able to guess the option what should be the second value. And sometime it happens that in a flow you go for a switch 16 and you come to this default I is equal to 4, 16 plus 4, 20, and you come up with answer as B. That is basically wrong, because we do have I plus plus, and with the timing means when it will be executed, this increment operator or this expression is the last statement of the body of the loop. So after printf we do have I plus plus in this case, and that will make 16 to the variable 17, and next time when the switch will come, switch 17, and it will directly go to the default value, and that will become 17 plus 4, that is equal to 21. Printf, the second value it will print is 21. I plus plus will make it 22. 22 less than equal to 20, that is false, and it will terminate. The very small concept of the switch here in this case is, and the concept of no break and no break subsequent cases will be true. The answer for this question is C. 16 and 21, that is the value will be printed by this program. What is the takeaway? The takeaway is still the same, that for switch, break is not there, all the cases will be true. Even if suppose the switch goes to 5, then 5 and default will be executed. So answer for this question, the small question related with the switch statement, is 16 and 21. Let's move to the next question. Now finally we have actually arrived to the part which is we find difficult or difficult to solve, and that is now related with pointers. So now here we have a main function, but apart from that we do have a foo function and the bar function. Within this bar function we do have integer pointer, integer C as a pointer that it is executing in this. And foo function is having a variable. Now the only thing here in this case is a variable. You see there are a variable which is a global variable. A global variable, and we do have a local a as well, local variable a as well, local a. So we do have certain variables, and we have one printf, two printf. I'm just highlighting the printf over here. In the meantime, you can go ahead and solve this question. There is another printf, and that is the last printf. Now the question is the sum of the values. Okay. The sum of the values printed by the program is, it will print 3 different values, and in this question we are more interested in finding summation of all the 3 values. So main function is having a is equal to 10, but again here you identify that in this case there is a scoping rule. And it is already said that this is a C program. Then in C program the scoping rule is a static scoping rule. What is the static scoping rule? Look at outside of the opening and closing bracket. This is the scope of the variable. Look at outside. Do we have any variable outside? Yes, we do have a global variable outside. Global variable, another property, their scope is static, and by default they are assigned to 0. But here we do have an assignment for a is equal to 10. So by default this variable is assigned to 0, but we have another assignment that is equal to 10. So here we do have a function which is called bar a, and I'll declare a variable a which is equal to, here in this case, is 10. And now we have an address, and that address has been passed here as parameter. Bar a address has been passed. So here we do have a pointer C which will have an address, and I'll draw this map for you. Suppose this address is 1000. So now we are passing the address of 1000, and that is stored by the variable C in this case, C. C will store the address 1000. Now we have another variable a which is local variable. So I will use a local, another variable. This is what a global variable. So there is a variable a which is local as well as global. Now, so let's see, a local variable, dereference C plus 2. Now what is the meaning of dereference? Dereference means you follow this Follow the address. What address you are going to follow? This dereference. That means do not print 1000. Go to the location 1000 and print the value. Now dereferencing operator use indirect addressing mode. Addressing mode in computer organization. Indirect addressing mode. So go to the 1000 and print the value 10. A is equal to 10 plus 2. A local will be assigned with the value 12. A local will be assigned with the value 12. So A12. Then you are calling the function foo from this, and with the variable A, which variable you are passing? A variable. So B will store the value, B will have a copy of the value actually, and that is in this case is 12. So here we have passed address of A, but here only we are passing the value, and which is 12. 12 will be copied to another variable which is B. Again you are saying B is equal to B plus A. So B is equal to B which is 12 plus A. Which A you will refer here in this cases? Local or global? So in C, outside of this brackets and outside of the bracket, A has a global value and global variable assigned to the value 10. So in this case it will become 12 plus 10, and that is equal to 22. Hope you agree with me on this. Dereference C plus 2, that is equal to 12 over here. 12 we are passed as a parameter, and this is B is equal to B. B is 12, 12 plus A, and A value is 10, so that is equal to 22. The first value is 22, that has been printed over here. The first value it is going to print is 22. Now it will return from this printf B 22, and then we have a dereference C is equal to A minus 1. What is A local? 12. Dereference C means you go to this location and A minus 1. What is A minus 1? So now that will become A is 12, 12 minus 1. This value will be changed to 11. 12 minus 1, this will become 11. And then you say printf, the second value that you are trying to print, A. Which A again you are going to print in this case is the local A. AL, what is the AL? 12. The second value it is going to print is 12. The 22 and 12. Finally, you will come back from the bar function and print the value of A, but now the A value has been changed to 11. The third value that is going to print is 11. The question, as I already mentioned, the sum of the values printed by this, and in this case this is 23 and this is 22. The value it is going to print, the sum of the value that it is, the quotient is your 45. 45 is the answer for this question. A good mix of everything, passing the value, passing the global, passing the address, two copies of the same variable which is A local, A global. Carefully we need to be see here in this case is which variable is getting modified, global or local, and finally printing the three different values, and that sum to 45. Answer for this question, which I hope you are able to follow, is 45. And like here as the answer mentioned 45, now we do have certainly a big mix up of local, global, pointer and values, passing by pointer and values, and that makes the program for pointers difficult. Okay, so here for this particular question I tried to convince as much as convincing as possible, but I hope that it is clear to you, and we'll move to the next question. So answer for the previous question 45 and 22, 11 and 12, that is the sequence of the value printed here in this. One more question which is from MSQ, multiple select choice question, and we do have a function which is given to you, and these are the different properties related with the function, the behavior of the function actually. So function is very simple, and I believe that that this is totally doable in the examination, that is that category of the question. Some questions are, yes, difficult, but in the actual examination there is a good mix of doable and not doable, and easy and very hard. So yes, it is that category of the question in MSQ that is totally doable, and you can figure it out the answer. Let's read the function here, what this function is doing. Foo int b, and again we do have a static integer which retain the values during various function call initialized to the value 10. We have an integer c, and we have a check whether a is exactly equal to b. A is where a is coming from, a is a local variable, and b is coming from the parameter that has been passed. If they are exactly equal, then we are again calling this foo function without modifying the value of a. So notice this thing, that here that we are calling this function, if a is exactly equal to b true, that means a is equal to b, and here we are calling the function without modifying the value of a, because b and a parameters are same, and that means there is no requirement of for a recursion there should be increment or decrement, or the value must diminish or reach to the condition, terminating condition is not happening. And this is your rank here in this cases. My rank will be 1. And finally return 0. Else part is for this if then we have this else return value 0 in this case. So now you can sense that after reading only you will be able to understand that this program is not terminating for certain things. Now let's read out the options. The function returns 0 for some values of b. The function never prints the string my rank will be 1 for any values of b. The function returns 0 when b will be 10. And the function will exhaust the runtime stack when b is equal to 10. So there is a runtime stack and this function will exhaust. Now let's analyze the statement by statement. The function returns 0 when for some values of b. Now is it possible this function will return 0 for some values of b? So there is a two return statement. One is here within if, and another one is here, that is return 0. Now if I pass the parameter which is a is not equal to b, if I pass let's say 1, 2, 3, anything other than 10, okay, in that time a exactly equal to b will be false and it will come to the else part and return 0. So yes, there exist not some, many values, but not all, for which it is going to return the value 0, and that seems here in this case is a true statement. The first statement, A statement, seems true in this case. A is true. The B function says that the function never prints the string my rank will be 1 for any values of b. Can I go to this statement my rank will be 1 in this case for any values of b? Now suppose if I take the value for that, this condition must be true, a must be equal to b, that I must pass the value as 10. So if I pass the value as 10, 10 is equal to 10, then c will become what? Again you are calling the function with foo 10 only, right? So you called foo 10 and again it is calling foo 10, and again the same thing will happen, that 10 is equal to 10, again it will call foo 10. So that 10, 10, 10 will be keep on calling, and you will be never able to reach the statement my rank will be 1 that you should do. So I find the B statement also as true, that the function never prints the string my rank will be 1 for any values of b. Yes, for any values of b it will never print the value, and this seems to be also true. A is true, B is true. The function returns 0 when b is equal to 10. When b is 10, it is not returning anything. It will be keep on calling foo 10 only. So this is false. The statement is false. And the last one is the function will exhaust the runtime stack when b is equal to 10. Yes, it's not an infinite loop actually. It is not an infinite loop. There is a difference between infinite loop and abnormal termination. Now in GATE 2017, 2017, there was very beautiful question with foo and bar, where they have written a code, and check in your GATE question bank, where we are having two function foo and bar, and one was abnormally terminating. Why there is an abnormal termination? Because of this reason, once you start putting the activation records on the stack, runtime stack, there is a limitation, there is a memory allocated to it. Finally what will happen, that it will overflow. That overflow situation, it is saying that as abnormal termination, or it will exhaust the runtime stack. Infinite loop is a situation where it is stuck in a loop. There is a single activation record that is present in the stack, and it is repeating on that. That is infinite loop. So there will be no abnormal termination until you are forced it to terminate. Forcing the program to terminate. It is not stopping. So both this concept, based on this concept, there was a very good question asked in 2017, where one of the function was abnormally terminating because of this stack overflow. Another one is going into the infinite loop, keep on calling each and everything. But here this is D, and this is also true, that it will exhaust the runtime stack. So A, C and D, that is the answer for this question. That C is false, sorry, A, B and D, that is the answer for this question. A is true, B is true, and D is true. Okay, so answer for this question is A, B, C is false, and D is true. A, B, D. But I do say that there can be only MSQ, because we have urge of marking the second one. You will be tested on this. Remember this, that there can be only one option also may be correct. Okay, so that is something about one more question. I have created two questions. I have discussed two questions related with MSQ, and which is sort of probability that you will get that that kind of type of question. We are expecting it. Expectation and reality may be different. This is the next question, and again I have created this sort of question only keeping the last year question paper in my mind. And here sometimes you notice that they don't mention that which version of the C compiler that you are using. So ANSI C program that it is mentioned over here in this case. And I'll say what this question is about. Let's first have this function. There is a foo function int defined here. There is a main function which is having what? Which is having simple for loop you have here in this. You simple for loop you are having, and you have a if condition into this. And then count is again being called with the value foo count here in this case. So now we have some count variable. This count is a local count variable. And we do have another count which is in the foo function, which is called here in this case is static int count is equal to 10. So there are two count variables, both are local, but among them one of the variable which is a static variable, static count. What exactly is the static count is, we have already seen familiar with the storage class, and it retains the value that you need to remember in this case. It will retain the value. Now for explanation purpose I have written this program in a single slide only, so that everything will be visible, and this part I can utilize for explaining this question to you. C program. Let's start executing the main function. Count is 0, int count initialized to 0, I initialized to 0, and we are running a loop from j is equal to -4 to 2. So it's my way of solving this, that whenever I'll get a loop here, I'll write the value for it. So j is equal to -4, j is equal to -3, j is equal to -2, j is equal to -1, j is 0, j is 1, and j is 2. I write down the value so that I can keep track of my loops and proper values that are coming after it. Now for I equal to 4 it will run, and count is 0. So local count here in this case is, I'll say count main subscript main, and that is equal to in this case is 0. I do have another count which is count foo, so I'll write here that count here in this case is count foo. So the complexity of the execution of the program we need to handle in a better way so that I don't need to rewrite the thing again and again. Now I'll go to this part here. If j greater than equal to 0, minus 4 greater than equal to 0, now this is false, right? Minus 4 greater than 0, this statement is false, and we do have a AND operator. Logical AND, bitwise AND we have already seen, logical AND. Then we have next part here in this case is I plus plus. Now the concept that it has been focusing on, and last year also the same type of question was there in the examination, was short circuit code. And that means this first part is already evaluated to false. It will never go to the second I plus plus. So I plus plus will never execute. Why? Because for AND, if this one is false, the expression is going to be false, I plus plus will be never executed. So it will never execute I plus plus, and this function call will not happen. So we are happy because less calculation, rest part is there. I plus plus will not happen, and in this case if I treat the value I will remain 0. So I is equal to I plus plus, short circuit code and operator, only this part will be executed, it will not come to the next part here. Similarly for 3 also, minus 3 I will remain 0. For minus 2 I will remain 0. For minus 1 I will remain 0. Minus 1 greater than 0, greater than equal to 0, false. Now for 0 here in this case is z greater than equal to 0. What is this? True. Then I come to I plus plus. Now this is again post increment operator. Be careful with this. Because if you do I is assigned to 0 and you just increment it over here, that will become 1 and the condition will become true, and you call this foo function. The problem is I will be tested. I is still 0. And that means this is true, but now this is false. I is still 0. But incrementation will happen after this. Count this function will not execute, but you are going to increment I in this case. So for I is equal to 0, I will become 1. I will become 1, but foo function will not be executed. Then for I is equal to 1, now we are here that I is equal to 1, 1 greater than equal to 0. Now it is 1 will be tested, that is true, and I will become in this case is 2, I plus plus. So I will become in this case is 2. Now first time I'll call the value count is equal to foo count. Let's call the foo count in this case. What value you are going to pass? Count is 0, so you pass 0 here. So now this I will hold the value of the count, that is 0. Static int another count is there, and count is equal to count plus I. So now you are going to only add into this 0, and this count will have value 10, and that will remain 10 only. But you are returning the value count from this, and that count will be stored in this count, and this count will become 10. So what happens here? I pass the value count which is 0, that is becomes I. Count is equal to count plus I, that means 10 plus I, count remain 10, that is 10. But you are returning the count, and that you are storing in this count for main, that becomes 10. True, I is 2. Now j will be incremented, j is 2, less than equal to 2, true, j greater than 0, true, I positive, non-zero value, then in this case true, but I will be now incremented to 3. Let's execute. Now this time count you are passing here in this case is 10. 10 will be passed as the parameter. I will now become 10. Count 10, initialization one time, though it doesn't matter, but this statement will be not disappear, like it will not there. Initialization statement will not be there. Assignment will be there. Count is equal to count plus I, and this time it is 10, and that means this time the value will become 10 plus 10, and this time this value will become 20, and it will return the value of the count which is 20, and that you are going to store in this count value. So 10 will become the value will become in this case is 20. So now this count become 20. j will be incremented, j become 3, 3 less than equal to 2, loop is false, come out. Count is equal to count plus I. So 20 plus I, what is the I value? We have final value I, which is 3. So now this value will become 20 plus 3, and that will become 23. Printf count, and that value it is going to print in this case is 23. Answer for this question that is asked here, that the output of the program, A is the answer for this question. 23 is the answer for this question. What is the concept? The latest concept. Before that, there was no question asked in the GATE examination, consists of short circuit code. Now we know for AND operator, both should be equal to 1, and for OR, one of them should be 1. So for AND operator, if one of the part, first evaluation evaluated to 0, then it will not go for the second one. I plus plus is not getting executed. For OR operator, if there is a 1, we know that the overall expression is going to be evaluated to 1, this part will never be executed. So that is the concept short circuit code, and that's why it is explicitly mentioning the ANSI program. This explicit mention you won't find in previous questions. So I believe, yes, again, like this is a good question, I would say, that based on the same concept. What is the concept here in this case? The concept of the short circuit code, and answer in this case is 23. I hope you will be able to figure it out, the entire part. This is the calculation part here in this, and answer for this question is 23. Let's move to the next question. Answer for this question is 23. 23 is the answer for this. Sort of similar trend, current trend question here in this cases. And what is the concept it is based on? Let me say the concept, and this has been regular actually. Array and pointer. Array and pointer. And it is not about passing pointer or array of pointer. This is about implementation of array using pointer. Now just now I have already told you that how this bracket operator opens up. Like if I use this index A of I, we know that this is going to be equal to dereference A plus I. A is the base address, I is the index, pointer arithmetic has been used. This is equal to dereference I plus A. And this is equal to dereference, sorry, no dereference, I of A. Yes, there is a GATE question that was related with the string where they have used this I of A, and it like index is outside and the name of the array is inside within the bracket. But actually these statements are equal, all four are equal, because when the bracket will open up, this will be added, and that is the pointer arithmetic comes into the picture. Now this is for one dimensional array, and here we have, if we have the second two dimensional of array A of I j, then same concept will be used. We will first open up this A of I. So this will become dereference, what it will become, A plus I. Then A plus I, then we have a j. Do the same thing. Treat this as a single unit. And that means it will become dereference A plus I, and then we have a plus j, and one more time you can have a dereferencing of it. This is equivalent expression. If A of I is equal to this, A of ij is equal to this. If I know this concept, this question is very simple. Now the question says that consider the following C program and its NAT numeric answer type of the question, and we do have a main function where array is size of 5 cross 10, and we have a loop which is running from 0 to 4 and 0 to 9, and this is the initialization part. ARR of ij is equal to 5 times I plus j minus j. And then finally it is saying printf dereference ARR plus 3 and then plus 8. Now certainly there is, it is this in this question, it is using one formula, this part as a formula for value of it. And if you are familiar with the notation, this is nothing but ARR 38. Now each values are being stored, and it is asking basically what value will be stored in ARR 38. If you are familiar with this, you are done with this, because this is the expression you have to use and you will get your answer. I believe some of you have already answered this question. ARR 38, what is ARR 38? So that will be equal to ARR 38 will be equal to 5 times I plus j, that is 3 plus 8 minus j, which is equal to 8 in this case. This is the value, 5 times 11 minus 8, and that is equal to what? 55 minus 8, and that is equal to what? 47. 47, we don't need to compute entire loop over here. I don't need it because the value is independent. Each value is independent. So the question here is that what is the value printed by this? This is the computation AR38. As soon as you figure it out that this expression is AR of 38, you can directly compute the value without skipping this first part, and without doing extra calculation you can come to this part. Answer for this question is 47. 47 is the answer of this question, and this has been the trend for this array index and this pointer association. Okay, so that is the thing that is latest. Latest means that is previous year also and GATE 2020 also. There is a single question targeting the array index property, and it is very simple. Okay, this thing is open up like this is this, and this expression is equal to AR 38. So I hope this single mark question is clear to you. This is very let's say simple question. Until you figure it out that this computation is an eyewash, you don't need it. Let's move to the next question. As I just mentioned, answer is 47 for this question. This is the first instance in GATE 21 set 2 where explicitly the concept of big Indian and little Indian is asked. The question was not related with C program, but I believe that we can have a C program exploiting this particular concept like this. So very simple program that I have taken, and data also have kept simple so that understanding will become better. And this is totally dependent upon the architecture, so you may get some different answers, and same answer if your architecture is a little Indian architecture. Now what this question is about is this, that I have taken a variable a is equal to 259, and for storing the value 259, single byte is not possible. Okay, in a single byte it is not possible. So I need to represent 2 byte, that is 256 plus 3. and I need this. Let me read the question first. Integer is 259. Then we have a character pointer. Now we know why we are taking character pointer, because character pointer points to only single byte. In C language, character pointer points to a single byte. Now we are address of the address of an integer, we are typecasting it to character pointer. That means we are narrowing down the address part. Like here, integer pointer is going, address of will be pointing to, let's say, size of integer, maybe 4 byte, maybe 2 byte, but we are narrowing down by this typecasting. Now it will point to only single byte. So this is the conversion, narrowing conversion in this case, and there can be widening conversion as well. Then I am printing the value C, that which value it is printing, which address it is pointing. So only one, like here, one statement, two statement, only two statement program, and the variable is 259. Now these are the option that what value it will print, whether it will print 1, it will print 3, 259 cannot be predicted. And I hope that some of you are very good in this and you have already answered this question. Let me write 259, and I know that I can understand that it is not possible to store in a single byte. I need the 2 byte of the information, 00 and 0011. Now, this is the least significant bit, which is this, and this is the most significant bit here in this case, is that this. Byte-wise, this is a lower order byte, this is a higher order byte. So we have a 2 byte. But now this character pointer is going to point only to a single byte. So now either it will be this or it will be this. Now in Little Indian architecture, this is the concept of the Little Indian architecture. In Little Indian system, stores the least significant byte at the smaller address. Least significant byte at the smaller address. That means here we have, suppose this is a 32-bit number. There is a 32-bit number, and here we have 0D as the least significant byte and 0A as the most significant byte. So now when I am going to store the memory address A plus 1, A plus 2, the smaller address will be store the least significant byte. That is 0D will be going to store address A. I don't know what is the value of A. But the smaller address will get the least significant bit. So now there is, how to remember, so now little, smaller and least. All three are common term, little, smaller and least. So Little Indian architecture, least significant bit will go to the smaller memory location. All are synonyms. So when all are synonyms, you can remember that little, smaller, least. Smaller, little, least significant bit will go to the smaller memory location. And what is a big Indian architecture? Where most significant bit will go to the smaller memory location. Okay, so there is a, really to memorizing this is very easy in this case. And here coming back to our question, here in this is the least significant byte, and this will go to the smaller memory location. Definitely when you are narrowing it down 2 byte, 4 byte to single byte, it is not going to point to the higher memory location, but rather than lower memory location. And in this case, this is a small, least significant byte, smaller memory location. So this answer for Little Indian architecture, this will be equal to 3. So 3 is the answer for this question. And expectation wise, as we are discussing the expected number of question, then last year there is a question from the Little Indian architecture. This year there may be a question from the Little Indian architecture, expectation. Okay. So analyzing the question asked in the previous year, because it is believed that, and I also following from the many years, that the recent year question have a more reflection on the current paper than the previous year, previous time that time they were organized. Yeah, topics can be, topics you can focus on, but the question have more reflection of the current year. So we will go here in this case answer as 3, and here I have written a commented out statement printf. percentage D, and then I have incremented the character pointer plus plus, and I dereferences it. So if the C is pointing to the lower order byte, the plus plus will increment the address, A become A plus 1, and then dereference it. It should print the second printf. If it is a Little Indian architecture, it should print the next value as 1 in this case. If it is a 4 byte of the space, 2 more time plus plus you can do, those value will be printed as zeros for a Little Indian architecture. For Big Indian, opposite, 0, 0, 1 and 3. I hope I am able to make you clear the concept of Big Indian and Little Indian in this, with this small program. Expectation is there for question from this topic. But again, since it's architecture dependent, there may not be question from C, but maybe in other way they can ask. Let's move to the next question. Now, this is again a question which we are dealing with array and pointers. And by this time, array and pointer actually. So this is the third question I am discussing with array and pointer. And by this time, I believe that you are getting more and more comfortable with the index here. But the problem here is that we have an expression with, I cannot write 2 and 3, but rather I need to write double star A. So we do have a double star A in this case. And what is double star A? So for that I can say that you are not adding anything into this, and I can write the double star A in this way. I hope you'll agree with me on this. The double star A can be written in this way. And for two-dimensional array, like one-dimensional array, single pointer is there. For two-dimensional array, there is a double pointer. And double star A is nothing but the value A00, right? A00. So now double star A is there. What is double star A? A00. And I come here in this case and I'll put the value A00, which is here 0th row and 0th column, which is 1. I put the value 1. Now I am able to make my expression same like before, that dereference, then dereference, and then there is a, and then there is a plus 3, and then outside there is a plus 3, and now my expression is complete, and with that I can say this is equal to A of 3, 3. No calculation required. If you want to go deep, I need to explain you the pointer arithmetic of array, but we will not do this. We want to solve this question as early as possible. There is a more deeper concept here. I'll just say a few words regarding this after this, but let's first find out the correct answer. Third row, third column, 0th row, first row, second row, third row. I'm in the last row. Third column, 0, 1, 2, 3. Third column, 24. Answer is 24 for this question. For this question. We are done with this. Straight away mark 24, move forward. Now concept wise, as I was saying, that I'll say there is a more deeper concept related with this. Now in case of C language, this two-dimensional array are represented, even if you feel in the initialization part. Look at how it has been initialized actually. This initialized as array of array. It is not a two-dimensional array, is what? We have individual element as an array. So now there is a data type. What are the data type here in this case? Is there is a data type A. When you take the name of the array, it represents the address of the first element. What is the first element of the two-dimensional array? What is that? Each element of the two-dimensional array. So each element of a two-dimensional array is a one-dimensional array. each element of the one dimensional array is an integer. So there is a 3 data type A, dereference A and double dereference A. Now for more deeper understanding, how does it work? We must know the definition of A, dereference A and double dereference A. A is the address of the first element of the array, which is basically this represent address of 1D array. This is the data type, address of 1D array, one dimensional array. That means if I say only A, it will give me address of an array. If I do the dereferencing, then I'll get address again. Address of element, first element of the array, which is an integer. The second data type is address of an integer. And the third double star is finally your integer. So whenever we do this plus minus, we are basically playing with the pointer arithmetic. When you say A plus 3, you are not incrementing the integers, you are incrementing the size of the array. I can show you the address and I can do this calculation, but right now it is not required. And in examination you will not do this thing. Right? So that is the, I think, all for today's session. And we have discussed quite different types of the question. One thing that we have discussed very limited way is the recursion. So I have planned one session for this data structure, and in the data structure part we are going to focus on the recursion as well. So you may feel here that few questions are discussed in in less number, but that is okay. That is how the session goes. And here I tried to cover as many as different topics possible. Operator ranging from operators to the scoping rules to the array and pointers and few new concepts that has been discussed. My main focus was in operator and this the pointer, that was the more in number actually, but these are the different parts that question asks from. Okay, so I believe that the session is fruitful and you are able to follow everything over here. Thanks for watching. That's all for this session. Thank you very much.